All right, so I'm going to quickly walk through a do file with some of the skills and some of the commands that we're going to need for this week. And what I want to highlight here is I struggled to figure out these commands. And so I want to make sure you're clear on, because you're going to have to do some of this struggle on your own. So I want you to see that process a little bit. So the first thing I'll do is I import this data. And if I type browse here, or I could have opened it up there. I'm going to get the data up, and you can notice, first of all, notice that some things are in red and some things are in black. Stata is telling you which variables are being stored as words or letters and which ones are being stored as numbers. So our amount is numeric, and then ID, measure, and sport are what we call strings. Let's see, str2. Two, it refers to the length of it. This is an integer. So it's telling you that. Now, the first thing you might notice is that ID right here is, I don't want it to be a number. Let's say that this A and B doesn't really matter and we want to cut it off. And so I need to figure out a way to get just the number out of ID. And there's lots of ways to do that. You could just get the first character there, because the number is always the first character. But there's this really cool idea called a regular expression. And a regular expression is a way to like match a string. So I'll just show you the first site that I went to so you can start to see a little bit of the struggle. So I Googled extracting string in Stata. I come across this UCLA thing. I'm kind of scrolling through and I see, okay, so here's a command. Let me look at that command. Where they're trying to extract a series of numbers, one that's 0 to 9, another that's 0 to 9, another that's 0 to 9. And I came down, I actually found one that was even better for our purposes. Well, something like this. I ended up adapting something like this. And so this is where I get the command from, but it really took reading this, and this took 10 to 15 minutes to read through. So I think I ended up using something just like this. And I had to read this. I mean, there's kind of no way around that. This UCLA site comes up a lot if you do queries. And so I know about regular expressions in that this website's actually really useful in order to play around. And so I'm going to put something down here. Like I'm going to put a regular expression. And then up here, I'm going to type like some code in, and it's going to tell me what part of this is matched, what part would be returned. And so if I type 2A, it highlights it because that would be matched. But we can do more general things. If I do, looks like right here, if I do a sequence like that and I put it in brackets, it's going to give me, it's an OR, so that's A, B, or C. So if I put in this expression, I would get just the A. But I want to get just the number out of here. And so I'm looking for something that's saying like just a number. Word, not word, digit, character between. And so I don't even know if they have a specific example here. You can Google regular expressions and there's stuff out there all the time. But in a similar way, I can do the 0 to 9. And that's basically going to say, give me any number that's 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. And that's going to be what I want. So pointing you in resources and give you just general thoughts of what I did. And so how I'd read this code is this says generate a new variable ID, which is take a regular expression by turning ID, this current column, and extracting 0 to 9, and then the plus says, give me however many numbers there are. Don't just give me one number necessarily. So if I go back here, let's say this was 22. See how it's not matching all of them? It's matching, like, there's little spaces there. Well, if I do a plus there, it's going to connect them all and say, okay, 0 to 9, like, give me all of them back. And so if I run this, I get ID. And so that looks pretty good. I generate this ID column. That looks pretty good. But you're going to notice, is Stata still thinking about it as a string? It's still red. And so I had to Google like convert. Oh, that's not what I want. I had to Google convert string to numeric, and convert string numeric Stata. And so I saw dstring, I see this encoding, I see numeric to string. That's opposite. I have a string and I want to do numeric. So this is what I ended up, because I want to convert string to numeric. So I end up on this page, and this is the command that I end up stealing: encode region and generate region 2. Well, we're going to do something else. We're going to encode ID. So we're going to encode this variable, and we're going to generate new ID. So it's going to take this old variable and make a new variable, which is numeric. So now new ID, and we don't need to get into the nuances. This is blue. Basically, black and blue both refer to numbers. Stata thinks about them as different. It stores them differently. Some are bigger than others. And then notice I don't need this old small ID and this big ID, so I'm just going to drop those, which will get rid of it. Now, the other thing you might notice is that, and we'll talk more about this, but I want to reshape this data. Like, I have each student twice here, and it would be nice if it was student ID, height, weight, and sport. Like having a variable of measure and being like, oh, we measured their height and the amount was 62, and we measured their weight and the amount was 200. And having these units being different within amount is a little bit weird. And so I looked it up. There's this reshape command, and what this wide says is currently this data's long, and I want it to be wider. I only want there to be 4 rows, but I'm going to make an additional column. I'm going to have two columns. I'm going to have height and I'm going to have weight. And so what's going to happen to the data is it's going to become wider. And so I'm going to say reshape, make it wider. The numbers that are duplicate are these amounts right here, right? Like this is the weird variable. This is the one where I want to take the data and make it go wider. I'm going to split this column between 2 columns. This I, get that out of here. This I says where's the identifier? And again, I got all of this from, I put a link there. And then also there's a example. So, and really there's no way around it. Some people find it tedious. Some people enjoy the process, but there's no way around of kind of digging through this slightly tedious, not the best writing sometimes, and just finding a good answer and simplifying it in your mind. But this I says, how do I identify the rows? Well, we're going to identify them based, how am I going to match up this height and this weight? Match it up because they both have the 1 there. And then J says, what do you want the new variable names to come from? Well, I want the new variable names to be height and weight. And then there's this extra command string, which I need because measure is a string. And the only way to really digest that is to play around with it, but I'll run this code and I'll show you what happens. Notice how it went from long to wide, amount switched. My new variable names, it concatenates is the fancy word, amount height and amount weight. And then so now we have a data frame that feels better to me. And maybe you don't love these variable names. You could rename those if you want. But this feels like a better structured data frame that I feel like I'm going to be more comfortable using. And now I'm going to talk about just simpler regression. So you regress a y, you have a dependent variable that you try to explain with an independent variable. So let's see if we can predict a student's height with their weight. Let's see the degree to which that works. So it's just regress. And so there's a lot of output here that is a little bit confusing. I'll point out what I think is the important stuff here. So first of all, the coefficients. So the constant is, the intercept is 109. And then the slope here is negative 0.24. So if you're going to write this, it'd be amount height equals 109.25 minus 0.24 times amount weight. And so there's your equation that you would use. And then you probably wonder, well, are these variables significant? Does it look like these variables are significantly different than 0? Does it look like it matters that I have this in the model? Does it look like it works? And so what you're going to look there is you get a standard error and a t-value. You get the t-value by dividing the coefficient by the standard error. And then here's your p-value for the individual variables. So if the p-value is really small, remember, that tells you it's very significant, because it's unlikely that you would see such a large coefficient as the result of random chance. So think of the p-value as the probability of seeing the coefficient that big as a result of chance. Both of these are above 0.05, which is because we have this really small data set of 4 numbers. And so you wouldn't say either of these are significant. You get some more information up here. This probability, this right here, tells you the probability of the entire model being significant. And it turns out, because we just have 1, it just ends up being the same as this. And so you get a percentage of the variance that you're explaining, the R squared, and you get a few different statistics. One thing I want to point out to you is we're going to do regression with multiple variables, with multiple independent variables, where we're trying to explain, let's try to explain height with both weight and with sport. And so we say, maybe we can explain something about your height. Maybe basketball players are taller or something like that. So I'm going to try to run this. Now run into a problem, no observations. And so I have links here. You can see the links where I figured out what was going on there. It turns out Stata doesn't like strings in regression. And so I need to convert this string into like a numeric or a factor variable. And so again, I'm going to do what we did before, which I'm going to make it numeric. And this is weird because it's numeric, but it still looks like a string. And so think this is called a factor, where it's thinking of these as levels. And so it's really thinking of basketball as 0 and football as 1, but it has a label to it. If you look over here, we have, that's not the label that I'm referring to, but there's labels here, which is basketball and football. So it's blue because it's numeric underneath the hood, but it's actually thinking about it as a label. And so, don't do this. Because, so, then I have two regression commands below, which is one where notice the difference between these two lines. In this line, I add an I beforehand. And that is to indicate, that's to do a regression with a factor. So if I do this, it's going to think of sport number. It's going to think of basketball as being 0 and football as being 1. But if you think about it, there's no reason why basketball couldn't be 1 and football could be 0. There's no reason why football couldn't be 10 and basketball be 6. Those numbers are arbitrary. So in order to tell Stata that the numbers I'm using in the regression are arbitrary, you put a little I beforehand, which says, think about it as a factor. Think about it with different levels. And so I'm going to run this, and this will work now. And now I get the same thing. I should point out that I believe I misinterpreted this statistic. It looks like this well, no, I don't think I did. I'm not entirely sure. I think that's the probability of the full model being significant. So I think we're good. I was worried it's the same thing as something down here, but I don't think that's the case. We'll see more examples of that to test that. But now we have multiple. So now notice that we have 3 variables here. We have amount weight, we have the sport number, football, and then we have a constant. And Again, we have coefficients on each, and we can look at a p-value of each being significant. I just randomly made up this number, so it wouldn't make sense if we saw any relationships. So as expected, these p-values are all very high. The thing I want to point out is, how do you interpret things when we have multiple variables in it? And we can talk more about this in class, but you think about this coefficient and this probability as after having controlled for all of the other variables in the model. When you're interpreting each line, you think about it after having controlled for anything in the model. So we've already taken into account, when we're thinking about the coefficient being 0.96, we've already taken into account if the student is a basketball player or a football player. And so what this tells you is, for basketball players, for every pound heavier they are, they seem to be 0.96 inches taller. And for football players, we also have the same thing, but it's already taken into account whether you're a football player or a basketball player. And you'd interpret this coefficient the same way. After taking into account your weight, we're going to add 24 pounds for football players. Or 24 inches for football players. That's incorrect, because we're dealing with the dependent variables units, which is inches. I would have expected basketball to be taller, but again, I made up this data. So we'll talk more about that, and this p-value is the same. It's always after taking things into account. And so what ends up happening, if you have two variables that are very related, you might see both of them be insignificant, because maybe x1 is not predictive after taking into account x2, and x2 is not predictive after taking into account x1. And so you always have to think about it as happening at the end. And so oftentimes you'll run multiple different models to try to decompose some of those relationships.